All right, so today is Tuesday, the 7th of February, and we've got a couple other things to do. And unfortunately, I wasn't able to find any kind of instruction out there that specifically targeted this particular area of material. So we're going to try to do this freelance and see what happens. Okay. So take out your notes for a moment. All right, so we've already talked about an inscribed angle, and we know that an inscribed angle is half the measure of its intercepted arc, and the arc is twice the measure of the inscribed angle. But there's another look to that we haven't seen before.
You still haven't seen it.
I'll make sure to move it down.
This is a surprise.
And that is something that looks like this. Okay?
Do we draw
Kind
that?
of looks like this, where you have a secant, and this is a secant, touches the circle in two places. It's a line. And this is a tangent. So this is a secant and a tangent. And you have still the kind of look of an inscribed angle, because that vertice is on the circle. Vertice is on the circle. So if that's the case, and we're trying to find the measurement of this, but yet we're given that this is 30 degrees. Okay, this angle here is 30 degrees. The measurement of this arc here is still going to be twice the measure of this angle. It's a tangent to secant. It's still going to be twice the measure of this angle. So if the measure of this angle is 30, this arc would be 60 degrees. Okay? But that's not what we were looking for. We weren't looking for this one. We were looking for this one over here. So again, since a circle is 360 degrees around in circumference, around, right? Then the measurement of this arc that's missing should be 360 minus 60, right?
300.
So that means the measurement of x would be 300 degrees. The important part to take away from this is that even though we have this look, this is still considered to be an inscribed angle because the measurement of the vertex of the angle is on the circle. Just looks different. This is what we're used to seeing. We're used to seeing an angle, and it's done this way. Okay? But that's still considered to be an inscribed angle. It's still touching the vertice on the circle. Now, the other thing we haven't seen before is something that looks something like this. Okay? Something that looks something like this. Where you have this arc at 120 degrees. And when I say this arc, we're talking about this part right here. Okay? If this part right here is 120 degrees, what is the rest of the circle?
360 minus 120.
Yep, 360 minus 120, which would be 240, right? So here we're trying to find the measurement of an angle. We're only given one of the arcs. We can find the other arc by subtracting that arc from 360. We have this arc here at being 240. Now, when you have an angle that's created either by two secants, two tangents, this is two tangents, by the way. They're originating from the same point outside the circle. They're both tangent to the same circle. When you have any of those, and you have the angle outside the circle, the measurement of that angle is different than anything we've seen so far. The measurement of that angle now is not the sum of these two arcs added together divided by 2, but their difference divided by 2.
That would be 120 divided by 2.
So you have 240 minus 120, either times 1/2 or divided by 2, same thing, right? So the measurement of this angle would be
120?
60 degrees, because you're going to use the difference. You have 240 minus 120 divided by 2,
Okay, never mind.
which would be 120 divided by 2, which would be 60 degrees. Okay. Yes?
Well, does it always work, but you can just take the half of that one anyway, I think.
No. Can't take the half of this. You have to take their difference and then divide it by 2. Take the major arc, subtract the minor arc,
No, I just.
and divide it by 2.
Because it won't always be this.
It won't work that way all the time. Just happens to work that way this time, but only because I picked easy numbers. Okay, not because that's the pattern.
Decimals
So-
will.
Mr. Holden, let me get his question, then I'll come back over here.
Oh, I had the same question.
Same question, okay.
You can't ever get a decimal, right?
You can. Why not?
I don't know, I just feel like
Sure you can.
you got a decimal right there.
But here's the thing,
How can an
if
angle
every
work?
other problem I've done so far, I haven't had any decimals,
There shouldn't be.
and then all of a sudden I get a decimal, that's okay. However, if that happens, I'm gonna double check that problem first. I'm gonna redo that problem just to make sure that it was a decimal, okay? But you certainly can get a decimal.
How can an angle be a decimal?
I guess the same way you can put 3.5 gallons of gas in your tank,
With the credit card.
or 3.25 gallons of gas. Yeah, everything has decimals. You can have decimals anywhere, certainly. Yeah, it doesn't have to be an exact number, you bet. But yeah, if you're doing any kind of mathematical process, generally speaking, just for classroom purposes, they use easier numbers so that you don't wind up with a lot of decimals. But for the most part, that's a fallacy. It doesn't happen that way. Almost everything's gonna be decimals unless it's just exact. And how many times do you do something exact?
All the
Depends on what it
Not
is.
very often. What's that?
Depends on what it is.
Yeah, it depends on what it is. Exactly, yeah.
So, like, on our tests and stuff,
Mhm.
are there gonna be decimals, do you think, or?
It's possible. I haven't done those problems yet, but it's possible.
Alright.
All right, so here we have, so here we have now, because before we just did this one up here, well, sorry, the one on the other side, was two tangents, right? This is considered to be a secant and a tangent. A secant and a tangent. A secant and tangent created an angle at their point of intersection. You could do this. You could draw this one on out. But it creates an angle outside the circle. Anytime you have an angle outside the circle that is an intersection of either two secants, two tangents, or one of each, the answer is always going to be found the same way. You find the difference of the major arc of intersection, the minor arc of intersection, divided by 2. So this is the major arc between these two. This would be a minor arc between these two. You take 129, you subtract 61.
60.
You get 68. Very good, Jane. Very fast, yeah.
Oh.
68. and then you take that and you divide it by 2,
34.
which would be 34. So the measurement of this angle would be 34 degrees. Questions on that?
Yeah, I was just.
If an arc is missing, right? If an arc is missing, but I have the measurement of this arc, again, to find the other arc, I just take 360 and I subtract 110. The circle's 360 degrees. So if there's anything missing, I should be able to find it. If there's a problem that you're assigned and you get some information on there and you go, wait a minute, I can't find the measurement of that angle because I don't know what the other arc is. Trust me, there's enough information for you to answer that question, or they wouldn't assign the problem. Okay? Yes.
Okay, what if you have two 90-degree arcs?
So if you have two 90-degree
Would
arcs,
you
you
just
probably
do the same?
wouldn't have two 90-degree arcs, right? Because what would happen if you had two 90-degree arcs?
It's just like
The angle would be what?
180, but
It would be separate.
The angle would be 0.
0.
Yeah? Because if you had two arcs that were 90 degrees and you found their difference, the difference would be 0, right? 90 minus 90 is 0, and you wouldn't have an angle outside. So literally you could not have that kind of a mixture, because then the angle would be 0, and it can't be 0 if there's an angle.
What if your
Alright.
tangent was 90 degrees?
Again, a tangent can't be 90 degrees because a tangent is a line.
Oh, I didn't know
If that, or you're talking about the angle.
that. Angle.
The angle created was 90 degrees. Is that what you're saying?
That'd be a big
Yeah,
circle.
I guess it's possible. Because you could have, well, you'd have to have 180 degrees, right? So if you had 360, or actually, what would you have to have? So 180 degrees, if you had 210 on one side, and what, 30 on the other side of the arc? That would be 180 degrees, right? And then, yeah, but I don't think the layout of the circle will allow that, just because if you have 90 degrees, it's gonna go this way, and probably wouldn't meet the circle at the same place.
Yeah, just give me the.
All right. So this is the worksheet I kind of pulled up for you.
That doesn't look too bad.
Doesn't look too bad. If you look, this is something similar to we talked about at first, right? Let's see if I can get that a little darker. I don't know if I can. There you go. So this is something we looked at just a moment ago. This again is something we looked at just a moment ago, except for this is different. Look at this one right here. How the heck am I gonna find the measurement of this
Because,
if I don't know either one of these two?
You double it.
well, I
It
mean,
could
I
be
guess you
100
kinda know,
and...
because-
Wait.
Double 50.
Okay, so without plugging in numbers, how would I find, and when I say numbers, I mean without doing a plug and check, plug and check, plug and check, how would I find this?
360 minus 50 divided by 2.
No.
Nice try.
So let's look at it a minute.
Yeah, yes. Okay.
Yes, sir.
You would double the angle.
Well, let's look at it a minute. So what's our, if we call this right here x, right? If we call that missing value x, what would we call this part?
Why?
No?
Z.
No, you gotta have the same variable in an equation or you can't solve. If you have two different variables, you won't be able to solve.
So X.
What did we call this, how did we find the measurement of this arc? When we found this one?
X.
Question mark.
Yeah, how did we find it? We did it just a moment ago. We find this one,
You double 76.
76
You
minus
subtract
180.
this.
You subtract 76.
alright, so let's look at this a minute. We have an inscribed angle, right? We're gonna find the measurement of this arc right here. 76 times 2 is
152.
so this arc would be 152. If we know this arc, how did you find this arc, the one we're looking for?
Subtract 360 minus 1.
Okay, so now we're getting somewhere. 360 minus this. So if we're gonna call this one x, how do we find this one?
360 minus
You said it's a
X.
360?
If this one's x, this one is 360 minus x, okay? Now, the rule says we're going to take the larger arc, we're going to subtract the smaller arc, we're going to divide by 2, and that's going to give us this. So 360 minus x minus
50.
x.
Why 2 minus x?
This is one of them right here. This is the other one. We got to find the difference between those two, right? We got to take this and subtract that. Yes?
Yeah.
Okay.
So,
Divided by 2 is going to equal 50 degrees,
oh,
right? It's going to equal the measurement of that angle. So this arc minus this arc divided by 2 is going to equal this. How would I solve?
You
You
could
have to
multiply
subtract
50
it?
by 2.
Yep, we're going to clear that fraction. Multiplying both sides by 2.
And then it'd be 360 minus x is equal to
25.
100.
Right?
And then you could divide by 2, so you get
and
x
you divide it by 2,
wait.
so it equals 50.
You would minus 360, that'd be 100, that'd be negative 260, and then you divide by a x, something. You divide by negative 2, which would give you
100.
a positive something. Is that right?
Okay? So what are we looking for here? We're looking for the measurement of this, right? So let's see if that worked out. If this is 130, right? The bigger arc would be what?
230.
230, right? If you take 230 and you minus 130, you get 100. And if you take that number and divide it by 2, you get
50.
50 degrees.
Seems harder than plugging it.
But you see how we did that? We set that up first of all, just call that x. We did the same thing to this problem as we did here. We just took 360 degrees minus that interior arc, and then we just plugged it into the formula and solved for x. I don't think I have any more of those. I just wanted to get that
Oh,
one out of
thank
the
the
way.
Lord.
Are we gonna get that paper?
Uh-huh. If you look at the next page, this one here just says, listen, state if you have an inscribed angle.
So it'd be yes or
If
no.
it is an inscribed angle,
No, yes.
if it is, name the angle and the intercepted arc. If it's not an inscribed angle, then just say no, it's not.
Yes.
We don't have to explain why.
So,
When you have this kind of a problem, right, you want to make sure and draw out the chords like we did last time. Draw out the chords. If you know the measurement of this whole thing and this whole thing, right, you can find the measurement of this. So if I know this whole thing and this whole thing, I can find the measurement of this little one right here, because it is going to total 360 degrees. So you're going to have to kind of play with these and see what you got. What do you know about an inscribed quadrilateral?
it's in
Remember that a couple days ago? You had an inscribed quadrilateral?
There has to be 90-degree angle.
Not on an inscribed triangle,
Oh, no.
whose third side is the diameter, yes, it's going to have a 90-degree angle. But an inscribed quadrilateral is in the same section. What do you know about it? Do you remember?
Oh,
Yes?
opposite angles are supplementary?
Yeah. So opposite angles are supplementary. So the angles opposite each other are going to add together to equal 180. Okay? All right. So on this particular assignment, I don't want you to get too carried away with it, so I'm not gonna have you do the heavy algebra problems down at the bottom, because I don't want you to be spending too much time on that part of it. But I want you to understand the concepts of it. So what I'm gonna do is I'm gonna have you do
Days for me to do that.
the first 8 problems, and then the next 12 problems. So you're gonna do 1 through 8, and then 1 through 12.
Are we doing 2?
I'm sorry?
Are we
Yeah, if
doing
you don't-
number 2?
If you don't already have, well, you won't have number 2 done because you have it. So yeah, you'll have to do problem number 2 that we did together in class on your paper, but you know how to do it. So do problems again, 1 through 8, and then 1 through 12.